my intention is just to give you an idea about the services that we are working in the MEF. And of course, the idea is how do we automate them in terms, especially between the operators. So automating the management of these services. So I'm going to give you a glimpse of what these architectures are, and then I go into the management of these services. So if you look at the diagrams on the left side, this is the Metro Ethernet Forum architecture really. On the left side, you have a customer interfacing to the service provider with UNI interface. And if you see on the right side at the end, in the same way, you have another subscriber or the customer, again, interfacing to the service provider. Now, as you can see, there are two operators, and the interfaces between them is called the ENNI, and the interface within the operator network, the interface called the internal network interface, or INNI. And services, there are a number of services, but the maybe most well-known are the EPL, Ethernet Private Line, which is a report-to-port service, all Ethernet Virtual Private Line, which has multiplexing of EVCs in a single port. And also we have multipoint and the E3 services to deal with the broadcasting and the multicasting. And if you look at this diagram, this is like, let's say if I have EPL or the EVPL provided by two operators, and let's say the OVC the operator A on the left side is also acting as a service provider. So therefore, the operator A is buying a circuit from the operator B on the right side. And that's we call the access E-line service. And as you can see, the segment of the EVC is called separately. The segment in the operator A we call the operator virtual connection A, and the segment in the B we call the operator virtual connection B. And of course, on the right side, it's a similar thing for the Ethernet virtual private line. Now, we also have IP services. As you can see on the left side, we have point-to-point IP virtual connections. And if you have right at the top, you have the multi-point connections as well. So it's really a similar concept. We map from layer 2 up to the layer 3. And if you look at the bottom figure, that is really the layer 1 services, which is recently being developed. And we have, I believe, 2 specs right now. So, and that also shows you whether access to the area or whether the transport area, the transit area and things like that. So then basically layer 1, layer 2, and layer 3 services. Then we have this cloud services concept, and that's really the cloud service architecture. As you can see, those are well-known terminology. At the bottom, you have network as a service, and then you can build on top of that infrastructure as a service, platform as a service, and software as a service, communication as a service, and security as a service. Now, as you can see on the right side, I try to show that there may be some way to skipping those layers, and maybe you can build this stuff on top of the network as a service. So the actors of the cloud services architecture is, if you look at the subscriber on the left side, and then subscriber on the right side at the bottom of the internet. So what that really means is the subscriber can access using the private networks as well as using the internet for the cloud services. And within that is, I have a cloud service provider that may or may not own the facilities, but you say, let's say I have operators only providing the connectivity, so I call them connectivity operators. And then you have on the right side, they providing the applications, and we call it cloud operators. So therefore, really, actors are the users, connectivity, and cloud operators, and the cloud service provider. Now, we define standard interfaces between them, and that is between the subscriber and the service provider. We call it the cloud subscriber interface. And on the right side, you can see I break them basically into 2 categories. I call it connectivity UNI and also the application UNI. This is very, very fundamental. What we do basically is anything beyond the connectivity we call application, as opposed to the application term that is being used in industry today. And that is certainly, there are a lot of reasons for doing that. And as you can see, the protocol stack, the subscriber, cloud subscriber interface can be actually layer 1 to layer 7, or they may break into the connectivity and the applications. And in that case, connectivity will go up to layer 3, and the application go from layer 2 up to the layer 7. And that same logic holds if I have two operators, they talk to each other. Again, the cloud operator-operator interface, it could be the application ENNI or the connectivity ENNI. Now, again, the same type of protocol stacks. Of course, the attributes would be different, whether it is between the user and the service provider or between two cloud operators. So this is the way that we're trying to show this thing is the cloud application will ride on top of the connectivity. So therefore, I have cloud virtual connections between two endpoints. One endpoint could be the cloud application, and the other endpoint could be the cloud connectivity unit on the subscriber side. And at the bottom, as you can see, if it's going through the multiple operators, I again segment this cloud virtual connections. So each, the segment within each operator, again, cloud virtual operator connection A, cloud virtual operator connection B. So this is a little bit complicated of that picture to show you that how this thing roughly is supposed to work. If you look at the right side, within that hexagon, you have two cloud operators where you have two applications or two VNFs is service chained. And then the cloud connectivity, the connectivity operator provide the connectivity from subscriber to those VNFs that is formed in the service function chaining, and then you have basically end-to-end cloud virtual connections so that the subscriber will be able to utilize both VNFs. Now, of course, from subscriber perspective, he really doesn't know, or she really doesn't know what's going on inside the operator networks, but this just shows you internally what is supposed to happen. So then so by the way, the cloud service architecture is still being worked. Although we published this 5 years ago in a different platform, but it's still going on in the MEF, and hopefully sometime early next year we'll finalize that. Then we have SDN, which I think in the previous session, the Verizon representative talked about the standardized SDN standards. So that is true. We have been working in the MEF, and we already have one spec. Actually, we're working on the two other additional specs. And as you can see, it's the same concept that I have in the cloud service architectures. You have a subscriber unit on the left side, and then you have the endpoint for each connection, which you have a SD-WAN connection endpoints, and then you have underlay service. So, of course, the SD-WAN is an overlay service, and it is on top of this. If you look at it a little bit more carefully, you have underlay connectivity, but then we build the tunnel virtual connections on top of these underlay network. So I don't want to go further details than that, but as you can see, we're really using the same models as best as we can in the cloud service architecture and SD-WAN. There is a purpose for that. The purpose is can we utilize the tools and systems that we have been using, of course with some modifications, for the new services that we are developing. So now that's a kind of background for you. Let's look at the LSO. Probably you have seen this picture before. If you look at the left side is you have customer, the next one is the service provider domain, and the right side is the partner domain. So in other words, if Verizon is buying a circuit from AT&T, then the Verizon is the service provider, and AT&T is the partner. So in the customer, you have two interfaces are called the Allegro Cantata, but at the end is, so one of them is interfaced directly to the service orchestrator, and the other one is interfaced to the business applications or the OSS/BSS. Now, the interfaces between the operators or between the service provider and the partner, as you can see, it says Sonata. Sonata interface between the business applications, and the interlude interface between the orchestrators. And you'll see later on is Sonata is much more service ordering and things like that, but the interlude is more provisioning and on-demand modifications. So the LSO functions is really management functions. So if you are familiar with the FCAPS, It's basically service provisioning, service ordering, service provisioning, and also the fault management, capacity management, and all these. Of course, on top of that, we have analytics, we have security management, and so on and so forth. So maybe just additional terms, but nevertheless, fundamentally still the FCAP's functionalities that we support. Now, you remember the BA, which is business application, really nothing more than OSS/BSS. I wanted to mention this. If I go back to this diagram, just to quickly, you see the interface between the OSS/BSS or the business applications and the service orchestrator is legato interface. That's the internal interface, right? It is not really between two operators. But what happened is very interesting. ONAP picked up on that. So ONAP tried to develop the legato interface. The reason is ONAP wants to talk to the northbound, and that's the only external interface the ONAP has. So what we said, okay, we don't want to diverge from each other, so we start to work on the legato as well, which I'll tell you what that is. So the business application interaction with the orchestrator through legato is basically this. That is you basically look at for the feasibility of the configuration that you want to do, and also you initiate those service orders, and you get the status from the other side and things like that. But at the end is you tell the service orchestrator to basically configure those resources that you promised through the order. Now, all of these are part of legato. Now, there is actually, I should be very careful over here, some of them is supposed to be in Sonata level, and some of them is supposed to be in the legato level. But again, if you are talking about the single operator, then you only have legato, you don't really have the Sonata. Unless you have two different operators, then you use the Sonata interface as well. So now, what I'm going to show you quickly is one of the work that I have done is the MEF76. That is the on-demand modification of the service attributes. So I'm going to go through the inner loop quickly and then go to the Sonata and then tie that hopefully with the information modeling and the APIs. So if you look at here in the MEF76, we said, okay, maybe the customer would like to modify the rate. Rate is like committed information rate or access information rate, or maybe they want to change the quality of services. And maybe they want to change the uni modifications, and maybe deactivate the EVCs, and maybe change the VLAN addresses and things like that. Now, the way we do is you can do two ways. One is you want the changes to be done immediately. The other one, you want the change to be done in sometime in schedule in the future. The way, of course, I formulated this thing a little bit is, suppose if I want to change the rate, one approach would be I, as a service provider, I list my rates, and you say you pick any one of these things, and anything different than that, I basically reject it. That's one approach. The other approach is, I said maybe I'll just tell you what my increments are, and I'll give you the formula, and then based on increments, you tell me how many times increment that you want from the speed that you are at. So then also we have, of course, once you do the immediate changes, we don't allow the subscriber to to cancel the request, because you said immediately, so therefore we don't have a real window to cancel the request. Now, what immediate means is it could be for some in 1 minute, 10 minutes, maybe 15 minutes, whatever that is based on the contract between the service provider and the subscriber. But at least hopefully it is in the minutes, not more than that. So similarly, you can do the same thing for the future. You can schedule them. Of course, when you schedule the changes, it could be no end time for the schedule, or could be for the new rate, or could be an end time. So it's really the same situation. But the difference over here is you can cancel the request, of course, with certain time interval that has been, again, negotiated by the service provider. So there are also, we have timers, we have also quality of service parameters like TAR, and which is the ratio of the accepted requests versus the number of requests that we received. And that is also actually, let me say it this way. So if I have 100 requests, for example, maybe 90% of them are valid requests. And then I look at how many of the valid requests that I could deliver. Maybe I delivered 80% of that. So that will give that ratio as a quality of service parameter for this interaction between the service provider and the customer. So as you can see here, I don't want you to read this chart, but it's pretty complicated. But I can summarize it very quickly is if you look at the customer on the left side, it sends a request, says, I want to have such and such changes. So what happens is the orchestrator, of course, certainly first qualify, you verify whether this customer has that service and they can really change these parameters or not. And then you send a request to your partner, say, look, I want to have these changes. And similarly, you send a request to your management systems internally, say, I want to have these changes. Once you have those changes, then logical thing to do is you test your component, your segment. You test your segment to say, yeah, I'm okay with my segment, and therefore you can move forward. Additional option is, as a service provider, I may want to do the end-to-end testing before I say yay or nay to the end customer that really your configuration is ready. So that was one, and of course the Unify modification is a little bit more complicated than that. The Unify, it could be two of them. So in other words, I want to modify the rate of the both operator A side and as well as an operator B side. So there are some complications there, but anyway, all of them are documented in the MEF76. So let me come back to the Sonata interface. So the main difference between the spec, the MEF76, and really what Sonata specs are, MEF76 is as end-to-end. So that's the key. And I try to really define those end-to-end E-line services. But in the rest of the MEF specs are focused on the interface between two operators. So therefore, if you have the operator one on the left side, operator two on the right side, which is the XS E-line that we mentioned before, therefore, we only look at the exchanges at this Sonata interface. So the first one is the service order, XS E-line, and that's the spec MEF79. And what you do is, you as a user, you say, look, I want to have the service in location A. You probably give some geographical location or the street address, something like that. But then we have different way of really verifying a location. So therefore, once you enter those street addresses, then the service provider looks at see if they really match what they have in their database and so forth. And then once you do that, then you look at the register for the product qualifications. So register for that and then fill that the product order qualifications. And then once you do that, then service provider give you a list and you retrieve your list and take a look at really what kind of product orders you have. So it looks like my time is very close. So let me jump very quickly so you got an idea what's going on. It's similar situations in the inventory. So once you have placed the order and you look at the order list, once you pick one of them, then you say, I want to see what you have in your inventory. What means is, what is your inventory is UNI, what is your inventory ENNI, and of course the XS E-line circuits. So you do that. These are the SDKs, API SDKs right now that is available in the MEF sites. You can download it, you can work from that. Although they are not fully stamped by the MEF LSO committee, but they are available to use. So then the Legato interface, I don't think I want to go into this one. Just say a couple words on the information modeling. The way we do these things is we start with the information modeling. So these are basically the information modeling for the all MEF services. And then so this is maybe, this is another different details basically on the interlude IPS that we're talking about. So one more slide that I want to mention and stop there. In terms of the APIs, the way we approach the APIs is we really use the TMF APIs, for example, as our envelope API, an abstract API. So once we do that, then we build MEF specific the APIs. That's the approach that we have so that we can provide the MEF details and as well as what's been established in the TMF. And so the SDKs that we have today is pretty much follow the same path. Thank you very much. So hopefully I didn't exceed my time.
No. Thank you. We're at the end, but if there's a quick question, then all right. In that case, thank you, Mehmet.
Thank you.